Our next speaker, our last speaker, Katrina Owen, has a really, really fun fact that at least I think it's fun. I've known Katrina a really, really long time, and this is the first time this ever came up, and we've had long, deep talks about our past histories over many, many a beer. Apparently, Katrina flunked out of the circus.
True fact.
I didn't even know you could do that. How is that a thing? And then she was accepted to a master's program in engineering, is that correct?
Yeah, aerospace engineering.
Aerospace engineering. So she flunked out of
So
the circus.
Lesson for you kids: if you ever flunk out of the circus, just know you could always go into aerospace engineering.
These are the people designing the airplanes you took to get here.
They are not
They
clowns.
are failed circus people. They're failed carnies, is that? I don't know. Awesome. Well, that said, ladies and gentlemen, Katrina Owen.
Thanks. So I actually remember exactly where I was and what I was doing on November 10th, 2009. I remember Go dropping. Hacker News went wild, and I was completely nonplussed. I was like, why would I care? What do I need this for? I don't need this. Clearly, at some point, I changed my mind. When people ask me why I decided to learn Go, I usually tell them that I had this project that had a bunch of different programming languages, and I had a command line client that was written in Ruby, which meant that the Haskell programmers had to have this entire Ruby environment set up on their machine in order to do Haskell, which was silly, and a real pain in the ass, and Go solved this. Now, all of these things are true, and I like telling the story because it makes me sound pretty rational, but I actually learned Go because I met someone at a conference and they were really cool, and I had a good conversation, and I started playing with the language. So I'm not rational at all. In his closing keynote at GopherCon last year, Russ Cox said that for Go to be successful, we need everyone's help, and everyone isn't here. Which brings me back to the question of why people choose to learn Go. Now, it turns out the initial decision is not the most important thing. Once you decide to learn something, you have to actually start. And once you've started, unless you have some really powerful habits in place, you have to keep deciding not to stop. Your reasons to keep putting in the effort need to be stronger than your reasons to quit, which is kind of a roundabout way of saying that you need to be motivated. If everyone who decided to learn Go were able to maintain their motivation until they had become proficient in the language, we'd probably see a pretty dramatic increase in the size of the Go community. So this is an optimization problem. Now, I admit it's kind of a troublesome optimization problem in that motivation is not typically something that we look at as a system having inputs and outputs that we can affect. People are motivated or they're not. Their motivation is strong or it's weak. The internet is full of advice about how to increase motivation. You'll see things like think about who inspires you, or seek environments that make you creative, or find like-minded friends. It turns out science knows a lot more about motivation than life coaches do. According to science, there are at least 3 independent variables that affect motivation, and these can all be addressed individually. The first of these is subjective value. It helps to believe that the goal is worth working towards. If you don't see the point of something, you're going to be apathetic and unlikely to pursue it. The second variable is your expectations of success. You'll be much more motivated to reach a goal that you believe is achievable. If you think it's valuable but impossible for you to achieve, you're going to be despondent and unlikely to try very hard. The third variable that affects motivation is the environment. A supportive environment is going to be much more motivating than a hostile one. So if you think that a goal is both valuable and achievable, but the environment is hostile, then you will spend a huge amount of cognitive resources every single day deciding not to quit. So when we look at the people who are interested in Go, but who run out of motivation before they've learned it, these are the 3 dimensions that we can optimize: subjective value, expectancies regarding success, and environment. Now, I think that in terms of value, Go is doing really, really well. If you're interested in the types of problems that Go solves, people are, for the most part, aware of these reasons. So I'm not going to talk about that today. Environment is complicated and subtle, and it's got all sorts of squishy things like feelings and psychology that I am absolutely not qualified to talk about. But I have spent some time in the Go community, at events, in the Gophers Slack, and my impression is that the Go community is making a huge effort to be supportive. So I'm also not going to talk about this today. So given that a person has decided that there is some subjective value to learning Go, and assuming that they've found the environment, at the very least, mildly supportive, the thing that is going to make or break their motivation is whether or not they think that they can be successful learning the language. There are 3 aspects to this. First, you need to have some sort of actionable plan for reaching your goal. And once you have that, you need to believe that the steps in that plan will actually work. And then finally, you have to believe that you personally can execute those steps. If you go on Reddit and ask for recommendations for how to learn Go, overwhelmingly, you will be given advice that basically boils down to something like this. First, do the Go tour, and then read the language spec, and then write a lot of code. So I'd like to look at the ways in which this plan might fail to motivate some people as they embark on learning Go. Starting with the Go tour. So the tour is delightful. It's approachable, it's fun, it's interactive, it provides lots and lots of small steps, which sets people up for lots and lots of small wins. So what could possibly go wrong? Well, actually, not much. At the very worst, you might stumble across a slide that's a bit confusing, but if you already know how to program in some other language, the tour is a phenomenal first step. Now, there is one caveat. At the moment, knowing how to program is generally considered a prerequisite to learning Go. And I think that Go would actually make an excellent first language. I think that Go would probably be better for teaching programming than some of the languages that are currently in use today, because the syntax is small, the language is consistent, and it doesn't encourage magical thinking. And it has a compiler. There is strong anecdotal evidence that self-determined learners can learn to program using Go, but we don't really have many resources that are appropriate for non-programmers, and I'm not sure that we're in a very good position to create any right now. And that's because the Go community has an overwhelmingly large proportion of people who have deep programming expertise. Right? That sounds like it's a good thing, but experts have a hard time explaining what they do or how they know. They're completely unaware of the shortcuts that they take, the steps that they skip, and the leaps that they make. When your expertise is effortless and automatic, you have a hard time breaking your skill down into component parts, which makes it basically impossible to create good resources for beginners. So I'm going to consider people who want to learn to program as off topic for today and focus on people who are already programmers. So once you've successfully completed the tour, the next suggested step is to read the language spec. This is a little bit like suggesting that a novice cook read the list of ingredients for a Twinkie in order to learn how to make pastries. I have a degree in molecular biology and biological chemistry, and I actually know what pretty much all of these things are, but I don't know enough cooking or chemistry to turn them into a spongy, food-like thing. When I first read the language spec, I knew almost all of the words. But I was unable to extract meaning. Reading the language spec was an exercise in feeling stupid and inadequate. In retrospect, I doubt that anyone meant to suggest that you can only be a Go programmer if you know what extended Bacchus norm notation is. The spec is a detailed formal document. It's intended for language implementers. You don't have to be a language implementer in order to be productive using Go. All right, so you have done the tour, you've read or perhaps skimmed the language spec, maybe you got something out of it. Next up, you need to write a lot of code. For most people, if they follow this advice, then they will, at best, flounder around and accidentally learn something. At worst, they will put in a ton of effort, and all they'll get out of it is a mountain of misconceptions and a truckload of bad habits. Effective practice is focused. Right? This idea that you can learn to write Go by writing a lot of code fails at every single part of being effective practice. It doesn't specify any goals. There's no plan for what code to write, and there's absolutely no feedback mechanism. Motivation relies on having a good plan. You need to think that the plan works, and you need to believe that you can successfully execute it. Our general recommendations for how to learn Go are not a great plan. Right? They're unlikely to sustain motivation particularly well. That said, this plan totally works for some people. I'm going to go out on a limb and guess that these recommendations are absolutely fine for people who have deep expertise in programming. That expertise might come from studying computer science at university or from years and years of experience across a bunch of different languages and a broad range of technical domains. The Go documentation and the Go resources are outstanding. And they also assume a certain type of knowledge and experience that a lot of developers simply don't have. Now, I'm not saying that it's okay to be a programmer and not know computer science-y things. I'm saying that it's okay to be a programmer and not know them yet. There really is no one-size-fits-all when it comes to learning. I once worked with a guy who teaches programming, like he teaches people how to program for the first time, and he's a great instructor. He's fun, he's engaging, he's charismatic, and his teaching strategy is basically to throw people in the deep end. This worked for some people. They felt exhilarated. They soaked up as much as they could, and every once in a while they'd come up spluttering, but for the most part, they would learn and learn and learn. Others in the same class felt that same adrenaline, but to them it wasn't excitement. It was terror. It was a kick in the guts. And they didn't learn, because it's really hard to learn when you're panicking. So I tried to convince this instructor that we should build a curriculum that consisted of systematic, itty-bitty steps, lots and lots of exercises, lots of repetition, one fundamental idea after the other, start with isolated skills, slowly combine them, step by step, test by test. And it sounds logical, right? He hated the idea. He hated it. And this was a revelation to me. It turns out if you try to teach him using tiny systematic steps, he gets so bored. He completely checks out. It can't hold his interest. His natural inclination is therefore to throw everyone else in the deep end as well. And I'm at the other end of that scale, right? Throw me in the deep end and I will flail around unproductively. But give me a slog, a tedious slog of incremental exercises that culminate in mastery, and I will love you forever. So I want to make a few suggestions. Might help narrow the gulf between being introduced to the Go syntax via the tour and shipping production code effectively, with the caveat that people learn differently and nothing is going to be appropriate for everyone. There are a couple of things that people need to develop in order to cross this chasm: fluency and proficiency. The Language Hunters website defines fluency as what you can say when you're woken up in the middle of the night with a flashlight in your face. They describe 4 levels of proficiency. The first level is where you can express concrete ideas, but not in full sentences. Fin musique, grosse voiture, tai quai. The second level of proficiency is where you can express and understand complete but very simple sentences. You can ask questions, you can give directions, you can complain to the waitstaff that your coffee is cold and your beer is warm. And at the next level of proficiency, there's a lot more nuance. You can start having interesting conversations. You can tell stories. You can argue about who shot first. And the final level of proficiency is where you can have complex conversations that include social, economic, and political topics. So fluency is not the same as proficiency. You can have a high level of fluency at a very low level of proficiency. Gaining fluency in the simpler, more fundamental skills lets you ratchet up your proficiency. The fluency frees up your cognitive resources, making them available to learn the more difficult thing. So bringing this back from human languages to programming languages, level 1 proficiency is being able to write the syntax for a map or a function declaration or a loop. Fluency at this level means that you're not worried about where to put the braces or what type of quotation mark to use. Level 2 proficiency is the ability to write a trivial program using the basic functions in the standard library. And level 3 proficiency is about working productively in real-world code bases, solving real-world problems. And then level 4 proficiency delves into more esoteric, hardcore topics. The Go tour targets level 1 proficiency. But the goal of the tour is familiarity, not fluency. In order to gain that fluency, you need practice and repetition. I've spent the past few years working on a project called Exorcism that explicitly targets fluency at level 2 proficiency. So Exorcism gives you a bunch of little toy problems, then encourage you to submit the solution to the exorcism.io website. And this gives you access to browse all of the other solutions to that same problem. And also, people comment on each other's solutions, pointing out alternate approaches that they can take or potential improvements. And it's this conversation and exploration that makes your Go code look like Go instead of Java or Ruby. The goal of Exorcism is to quickly ramp up and get fluent with the syntax, the standard library, and the conventions of a language. After completing some number of exercises, someone who is learning Go should be able to solve a toy problem if they're woken up in the middle of the night with a flashlight in their face. And their solution will probably be more or less idiomatic Go. Once someone is comfortable with expressing themselves in the language itself, the next level of proficiency requires using real-world technologies. At this level of proficiency, you want to provide scaffolding. Don't make people start completely from scratch from a blank slate. Building things from scratch requires coordination of a lot of disparate skills, and at this stage, people don't have them. The easiest way to provide scaffolding is to provide small working code bases that do something real. So it might be a command line client that talks to an API, or a small web API that talks to a database and serves some JSON, or a program that munges some data from a CSV file, or parses a stream of binary data. It's not quite real world, but it's working code, and it's using things that you would see in the real world. And then you give people targeted tasks to accomplish in that code base. So they might have to troubleshoot some performance, or add a feature, or extract some functionality into a separate package, or add some tests, make something parallel, swap something out using a different library. Having these little targeted missions to accomplish will force people to read code. It'll give them a starting point for searching for solutions, experimenting, and reading documentation. Another type of resource that's appropriate at this level of proficiency is starter kits. So if you know nothing about brewing and you want to try it out, the recommended method is to get a starter kit. When you are just starting out, you're incapable of managing the complexity of making every decision about every variable yourself. And you shouldn't have to. You don't need infinite flexibility. You don't need perfect optimization. You just need enough to get started. So a starter kit is not a framework, right? We don't mean that you should use it forever. Much like with the targeted missions in the scaffolded code bases, this is another way to get people started just enough to run into a little bit of trouble, right? You want people to have just the right amount of frustration when they're learning. A little bit is energizing. A lot is not good. That's just demotivating. So getting to level 4 proficiency in Go isn't really necessarily about Go. It's about computer science, about language design, about architecture, and that is out of scope for this talk. There are 3 things that I think you can do today to help lower the barrier to entry in Go. The first is to contribute to the Go track on exercism, figure out which concepts people are struggling with, contribute new exercises to help people practice those concepts, review pull requests, help make the existing exercises more idiomatic. And the second is that as you do your day-to-day work, think about how you could create a minimal, isolated, standalone example inspired by that work. Right? Create small code bases that exercise real-world technologies and concepts, and for each code base, make a little list of suggested ways to interact with that code base to let people practice the code reading and code writing skills. The third thing is to create starter kits, different types of projects. And you're not making a framework, you're not making the be-all, end-all solution for how to write a thing, but it's a perfectly good, reasonable suggestion for how to make your first couple of things. Now you'll notice that my suggestions are weighted heavily towards exercises rather than blog posts and screencasts. This is deliberate. Skills develop when we produce, not when we consume. To successfully learn Go, people need an actionable plan that they believe will work and that they believe themselves capable of executing. And in the past, we've put the burden of creating this plan on those who are the least qualified to do so. And it's time we change that. Thank you.
Thank you very much, Katrina. That was great.